Hello Physics, this is Dr. Brenzy, and this is the fifth and final video on a series about Newton's laws of motion and forces. In this final video, we're going to be dealing with a block that is placed on an incline. So we have a 6 kilogram block placed on a 30-degree incline. It says the incline has a coefficient of kinetic friction of 0.2. What is the acceleration of the block down the incline? So let's review the steps that we need to take in order to solve problems involving forces and Newton's second law. So first of all, we need to draw a sketch. Then we need to create a free body diagram. The third step is we need to place the y-axis along the normal force, and that will be important especially for inclines. The fourth step is to break any forces into components along the x and y axes. And we need to do that in order to write F net equals ma, Newton's second law, for those two axes. And then finally we're going to have a system of equations that we're going to need to solve. Okay, let's go ahead and begin with step one. Let's create a sketch. So we have a 6 kilogram block on a 30-degree incline. So I'm going to draw a 30-degree incline. And I'm going to place that 6 kilogram block on that incline. It says the incline has a coefficient of kinetic friction of 0.2, so I'm going to write mu sub k equals 0.2. And then it's asking us what is the acceleration of the block down the incline. So it's asking us for the magnitude of this acceleration a. Let me redraw that sketch on another slide here to give me a little more room. Of course, you don't need to rewrite it. You have it in your notes there. And unlike the other 4 videos, what I'm going to do is actually draw my free body diagram right on the incline here, because it will help sort out what certain angles I need to use. And that will become clear as I go through the step here. So let's figure out, first of all, what is this 6 kilogram block interacting with? Well, it obviously interacts with Earth, and it interacts with the incline itself. So what forces are being produced by these interactions? Well, the Earth pushes on the block with a gravitational force downward, and the incline produces a normal force and a kinetic force of friction. Okay, these are the 3 forces that should be on my free body diagram. So gravitational force always points downward toward the center of the Earth. And notice that I erased this little baseline right here that I was using for the reference angle, 30 degrees. I want to erase that. The reason I erase that is because I've been noticing in class that a lot of people are trying to use that line in some shape or form. The only reason we need this line is to indicate to somebody that this is a 30-degree incline. Right here. That's all we need it for. Okay, now that I've identified the force of gravity, let's draw the normal force. And remember that the normal force is always perpendicular to the incline, or perpendicular to the surface. We have a surface that is slanted, it's tilted, so we need to draw our normal force perpendicular to that surface and not pointing straight up. So notice with an incline we don't have a normal force that directly opposes gravitational force. And finally, the coefficient of friction, or excuse me, the force due to friction, is opposite the direction of motion. This block is going to accelerate down, so the force of friction is going to be a force pointing toward the right. Oh, excuse me, the left, up the incline. Okay, so that is, these 3 forces right here make up my free body diagram. Now, the next step is to place the positive y-axis along the normal force. Since the normal force is pointing up but a little bit to the right, I also want to place my y coordinate in that direction, my y-axis. Notice that the positive y-axis is no longer pointing up. The reason we do that ultimately is so that this acceleration is completely along the x-axis, as you can see there. So this acceleration is all going to be in x. None of that acceleration is going to be in y. Okay, so now that we've identified where we need to put our axes, our x and y axes, we need to break down any of these forces, all of these forces, excuse me, not any of them, but all of them. So we definitely know that the normal force, all of it is in the y coordinate, so we don't need to do anything with normal force. The friction force is in the negative x direction, so we don't need to do any breaking down with that. However, gravitational force is not totally in y and not totally in x, so we have to actually break that one down. Now, the way to break this one down on an incline, because it can be so confusing, is what I like to think of as down and then a 90-degree turn. So go down and then turn 90 degrees. What do I mean by down? I mean by down as in opposite to the normal force. So I'm going to draw a line going down until I can make a 90-degree turn. So I go down until I can make a 90-degree turn to get to the gravitational force. So here's where I can make a 90-degree turn. So this angle right here is a 90-degree angle. So you can now see that we have a right triangle. This leg of the triangle is in the y direction. This leg of the triangle is in the x direction. And if you're not convinced of that, what you can do is tilt your head so that this looks like it's pointing straight up to you. Or if you even have a piece of paper, you can rotate your paper so that this positive y-axis is pointing up, and then you can definitely convince yourself that this is pointing down and this is pointing toward the right. Okay, now that I have that triangle drawn, I can use some trigonometry, but I need to know what one of these angles is. I need to know what this angle is or what that angle is. Well, it turns out that this angle is going to be the same as the incline angle. So this angle that we created right here is 30 degrees. Now we can use trigonometry. Well, here's my positive x and my positive y axes. If we were to turn them, if we were to tilt our paper. So this is what the free body diagram would look like if you tilted your paper so that y is pointing straight up and x is pointing straight to the right. And then you can see that this brown triangle right here is straight down and straight to the right, and that's 30 degrees. So now you can see pretty clearly that this is f of g times cosine 30 degrees. Because cosine is adjacent over hypotenuse. Oops, I went with sine 30 degrees first. And then this opposite side is f of g times sine 30 degrees. There we go, I forgot which order I put these in. So here's cosine. Alright, so now we've broken down this gravitational force into something that's completely along y and completely along x. And this is what it would look like if you chose not to tilt your paper, right here. So, what your free body diagram will look like after you've broken this down will actually take this force away and replace it with its two components, this component going down and this other component going to the right. So now we have all of our forces broken down into components. We need to be able to do this, or we need to do this so that we can write Newton's second law for the y direction. And we can write Newton's second law for the x direction. So I'm going to do that on another slide here. You don't need to do it on your paper, of course. You just need to go a little bit lower on your paper. So here's our modified free body diagram. And now we have Newton's second law in the x direction. So the x direction, we have F net equals ma. And the forces in the x direction are this one and that one. So we're going to add those two together. And that's going to give us mass times acceleration in the x direction. And that acceleration in the x direction is a. I've done a little bit of substitution here. I wrote mg to replace F times, or gravitational force. And then I replaced friction, kinetic friction force, with mu times normal force. So let's plug in some numbers here. And now we have an equation. Well, let's simplify this a little bit. Now we have an equation that has two variables. We can't get any farther with the x direction. So let's turn our attention to the y direction then. Let's again write F net equals ma. This time we're going to be looking at the forces along the y-axis, and we have normal force plus negative Fg cosine of 30 degrees, and there's no acceleration in the y direction, so that's 0. Right, I can replace gravitational force with m times g, and I can evaluate this. I can figure out what 6 times 9.8 times 0.877 is, and that turns out to be 51.57. So I have something that I can solve for normal force. So as you can see, though, we have a system of two equations, 1, 2, and we have two unknowns. This one only has one of the unknowns, so let's go ahead and solve that, which is pretty easy. And then we can plug that into this equation right here. And now we have an equation we can solve for acceleration. And we get an acceleration of 3.18 meters per square second. Okay, physics students, that is how you handle inclines. And hopefully this will help you in the future, and I look forward to talking to you soon. Bye.